What's up, guys? Welcome back to Chem 1 BSI. My name is Roane. Today we're going to be going over boiling point elevation and freezing point depression. The first thing I want to talk about when we talk about this subject, I want to mention that it's fairly math-based, and all of your answers will come from these two formulas down here. So you have a boiling point elevation formula and a freezing point depression formula. They're the same basic structure. That's delta T equals K times MI. What those variables mean or stand for is down here. So the delta T with subscript BP or FP is just the change in freezing point, which is FP, or the change in boiling point, BP, and those are in degrees Celsius. You have your KB or your KF. Those are just that's either your freezing point or your boiling point constant. And that is different depending on what solution you're looking at, what solvent you're looking at. So if you look at the table here, we have water, right? And then you have the KF here and the KB here. So you're going to have two different values depending on if it's the freezing point one or the boiling point one, depending on what solvent you're looking at. Okay, M is molality, so make sure you don't get that mixed up with moles or molarity. Okay, molality is something different. And then I is the Van Hoff factor. Okay, and the Van Hoff factor is just, in simple terms, how the molecule splits when you put it into the solvent. So something like NaCl, okay, NaCl dissociates into Na and Cl, okay, and because it splits into two separate things, 1, 2, your Van Hoff factor, or your I, is 2, okay. Molality, in case you guys are unsure, molality, we'll just go over molality. Molality is moles of whatever you're dissolving all over your kilograms of solvent. Okay, so it'll be moles of whatever you're putting into the solution and then kilograms of your solution. Okay, so that's what molality is. And then KB would be given to you in some sort of chart, I'm assuming, unless your professors ask you to memorize it. And then your delta T is usually what you're looking for, but not always, right? So, and the other thing I want to mention before we start is that during these problems, boiling point, freezing point, okay, they're going in opposite directions, okay? So if we were looking at water, okay, let's say we're looking at H2O, okay, freezing point 0 degrees, boiling point 100 degrees, okay? If I add something to my solution of water, okay, that's only going to change the boiling point by increasing it, and it's only going to change the freezing point by decreasing it the opposite way. Okay, they're never going to go towards each other. You're never going to lower the boiling point. You're never going to increase the freezing point. It's always going to be this way, and that's just good to make sure you guys know. Okay, so let's just go right into our problem. Okay, so our practice problem 1, I dissolve 0.4 moles of potassium iodide into 1.35 kilograms of water. What is the new freezing point of the solution? So, again, gotta figure out what formula we're using. You see freezing point, so you know you're going to be using the delta T FP equals KF times molality times I. Okay, so what is the new freezing point of the solution? So we know we're looking for this. This gives us our change in temperature, and if we want the new freezing point, we know we need that. KF, all we have to do is look in this column, and we have to see what our solvent is. Clearly we're using water, and our KF there is 1.86, so it's going to be 1.86 times molality. Remember, molality is your moles of whatever you're dissolving over the kilograms of solvent. Okay, that is equal to 0.296, so it's 1.86 times 0.296, And then potassium iodide will dissociate into K plus and I minus, which means your Van Hoff factor is 2. So multiply that by 2. So if you do all that, you will get a 1.0 change in temperature. Your change in temperature is 1.0 or 1.1, sorry. And remember what I said, whenever you're changing your freezing point, you're always going to decrease the freezing point. Okay, so I just have to add or subtract this number from the original freezing point of water. So again, we can look at our table. Here's our original freezing points. Water has an original freezing point of 0.0. So I just have to subtract my 1.1 and my new freezing point equals negative 1.1 degrees Celsius. Okay, so for our next problem, we're going to be looking for a different variable. This last problem asks if I add 0.65 moles of NaCl to 350 grams of an unknown solution, I add 0.65 moles of NaCl to 3,500 grams of an unknown solution. The boiling point of this solution increased by 1.25 degrees Celsius. What is the molar boiling point elevation constant? Okay, so see boiling point. So I know what I'm trying to find here. Okay, I know what formula I'm using. The one with the boiling points. Okay, what is the molar boiling point elevation constant? This time we are looking for our Kb value. Okay, that is our constant. We're looking for the boiling point elevation constant. Okay, so I have to just make sure I have all the other variables here. So I, again, Van Hoff factor, my I is 2. Okay, because NaCl is going to dissociate into Na plus Cl minus, so my I is 2. My M have 0.65 moles divided by, and remember, the bottom part has to be kilograms. Okay, so I have to change that to kilograms, so I'm dividing that by 3.5. Okay, that is going to get me a molality of 1.86. Okay, and then my change in temperature is already told to me. Sorry, I just want to do it a different way. My change in temperature of the boiling point is already told to me. It's 1.25 degrees Celsius. Okay, so now I can set up the equation having all the variables. Okay, I'm going to set it up so that I don't have to switch it around. So that's going to be Kb equals my change in boiling point over Mi. And all I did is divide both sides by Mi, and then I switched it around. Okay, so Kb equals the change, which is 1.25 degrees Celsius, over 0.186 times 2, and that is 3.37. All right, and that is our Kb. So fairly high Kb, right? But that is how you need to be able to do these problems. I hope this helped. If you want any additional help, feel free to check out the worksheet. And if you need any help with any freezing point, depression, boiling point, elevation problems, be sure to stop by our office hours. Thank you guys.